Okay, section 2.4 continued. We're going to solve right triangles in terms of application, that is word problems. And I'm going to give you a couple of guidelines to go by, a few details on definitions, and then we're going to jump right in and work some examples. Guidelines that you need to think about. You either have to draw a sketch of the scenario and label your information, or if they've given you a sketch, you need to label your given information. This is key, guys. If you cannot draw a picture, you're not working these problems. So be sure that you figure out how to get these sketches done. Now, once you've sketched your stuff, you need to choose one of your trig functions that relates your given information to the information that you want, and you need to set up an equation. I encourage you to limit yourself to sine, cosine, and tangent, because as we type that into our calculator, it's just easier to use those functions. And then lastly, you're going to solve that equation, and you're going to make sure that your answer even makes sense, just to see how everything is going. Now, as we look at these word problems, you're going to have two different things that are thrown at you. One is an angle of elevation. This is created from a horizontal line of reference. It could be a line of sight, or it could give you an object, but anyway, a line of reference, and it rotates upward from there. So that's an angle of elevation, obviously elevation meaning upward. And then you also have an angle of depression. From the horizontal line of sight, it rotates downward, and so depressing being down, that's the way you can remember that one. And so we're going to use those two terms as we go through these problems, but I wanted to just mention them before they hit us in the face. Okay, first word problem. Shelley knows that when she stands 123 feet from the base of the flagpole, the angle of elevation to the top of the flagpole is blah. If her eyes are this above the ground, find the height. Okay, let's draw us a flag. Now, guys, I just can't draw. Y'all hang with me. We got a flagpole, and we've got a person standing. If she's a girl, we'll give her some red hair. Standing here at the flagpole. Now, we know that this is 123 from the base of the flagpole to her. That's the distance. They also told us that the angle of elevation to the top of the flagpole is 2640. That is from her line of sight. So here is her line of sight, horizontal, and the angle of elevation upward to the top of the flagpole. Sorry, I can't draw. This angle of elevation is here, 26 degrees and 40 minutes. It also tells you that she, from her eyes to the ground, would be 5.30 feet in length. Now let's transfer some of that over here. We know then that this is 5.30 feet in length. We know if this is 123, that our other horizontal is 23. And we want to know the flagpole. We want to know this total distance here. We have a piece of it. We need the other piece. So I'm looking at this right triangle set up, and I'm seeing that we need this distance x. Everybody seeing that with me? Okay. So checking out my angle, x is opposite the angle, and 123 is adjacent the angle. I hope that most of you are yelling out tangent at this point. That's how we're going to find our missing piece. Tangent of 26 degrees and 40 minutes should be equal to the opposite, which we're looking for, over the adjacent. So altogether, x is going to be 123 feet times the tangent of 26 degrees and 40 minutes. That's going to be an approximate distance, but we can find that without any trouble. It is showing in the textbook that that amount is 61.8 feet. Now, that is this distance, and of course this is not drawn to scale. So if I want the height of the flagpole, I would have to take my 5.30 feet, which was the height from the ground to the eyes of Shelley, plus my 61.8 feet, which was the remaining height we found here, and I would get that the total height of this flagpole is 67.1 feet. Again, not drawn to scale, but that's the general idea. And I hope that wasn't too bad. Let's look at another one. The length of the shadow of a building, 34.09 meters tall, is 37.62 meters. Find the angle of elevation of the sun. Now, guys, I highlighted this for a reason. Angle of elevation of the sun. I want you to think about that a minute. If we had the sun shining and it was our point of reference, the angle of elevation would go up from there. That is not at all what they needed to say. What they needed to say, or better stated, is the angle of elevation to the sun. And then at that point, you need to know your reference point. That is assuming from the ground. Okay? So as you look at problems, and they do this repeatedly in this chapter, as you're looking at problems that talk about angle of elevation of the sun, you mentally need to know that we're talking about angle of elevation to the sun. And so let's talk about what we've got. We've got a little building with towers up in there. Okay. And that building is 34.09 meters tall. It casts the shadow of 37.62 meters tall. And what we want to do is find the angle of elevation from the ground, a point on the ground, to the sun. So we're looking at this, an angle of elevation from the point on the ground to the sun. And I want to just convince you that this would be the same thing. If the sun is here, and this is my reference point, the angle of elevation here, which I just drew it in a different way, this one and this one would be the same. Okay, but they might have said it better this way. All right, so let's see what we've got. We're looking for this angle theta. We have opposite of angle theta, and we have adjacent to angle theta. So I would set this up as tangent of my theta is the opposite over the adjacent. Notice our meters cancel. And now if I want theta, I hope you remember from last lesson, I would need to take the inverse of these two. And I encourage you to do this all at once so you don't have a lot of round off error. And theta is going to be an approximate for sure. And that approximate angle is 42.18 degrees. So it is approximately 42.18 degrees, the angle of elevation to the sun from the ground at the end of that shadow. Okay, so a little bit different. I saw a couple of those in the working, and I wanted to just mention them to you before they got too bad. All right, let's look at the last example. Let's see. Okay, this is an angle of depression. We haven't done one of those from the top of the building. So we've got a building. The building is our line of sight. It said from the top of the building, that's our reference point. The angle of depression to a point on the ground. They tell you that that angle of depression is 32 degrees and 30 minutes. So again, from the horizontal line to the point on the ground, which would be this way. And they want to know how far is the point on the ground from the top of the building if the building is 252 meters high. So what they really wanted to know is this distance here. I'm going to wave it down. They want to know this distance here. Okay, so we need to use something that we know. This is a horizontal line of reference. We're assuming our ground is horizontal. And this angle is equivalent to this angle. I know that because these are alternate interior angles. And we learned that they have equal value. So I can write this as 32 degrees and 30 minutes as well. Now, given this angle, I have the side opposite, and I need the hypotenuse. Well, opposite over hypotenuse sounds like sine. So sine of 32 degrees and 30 minutes is equal to opposite over hypotenuse, which is what I'm looking for. Well, this would be sine of 32 degrees, 30 minutes times x equal to 252. I'm just solving this for x. You could have just flipped everything upside down, but sometimes that bothers you guys, so I'm trying to step through that process. So I have 252 divided by the sine of 32 degrees and 30 minutes. These are meters. Uh, yeah, meters. Okay. And so when I actually work that one out, let's see if I can find this one again in my book. Yes, this would be 400, approximately 469 meters would be the length. And that makes sense because it should be bigger than our 252. I'm going to just check this on my calculator real quick because I just like to do that before I leave you with stuff. Let's see. Yep, 469. That's what I got to. So that's great. Okay, guys, bottom line, draw you a picture. And if you can't do that, you're going to be lost. Draw your picture. Usually they give you one. Once you do that, map out your information, see what you need, see what you have, pick one of your trig functions, and go for it. And then at the end, just make sure it's making sense. Okay, hopefully that was a nice, easy lesson. Nothing crammed down your throat. You've got plenty of problems to work on to give it a try. And if you have questions, remember we can just always ask them again next class meeting.